Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. Uh, my name is Associate Professor Dr. Mak Mezi bin Hilmi. In this today video, I'm going to talk about another chapter in the strictly mechanical engineering design textbook, which is beneficial for students in manufacturing engineering. So this subject you usually learn in year 3 in engineering subject lah, which called machine component design. Okay, I am referring to the textbook from Strictly Mechanical Engineering Design textbook, which I cover in this video is chapter 3.18 curve beams in bending. You can find this book. You can you it is better that you purchase this book from sources. Okay, so that you can refer to what I've said in this book. I hope this video will give some additional knowledge for what you have learned in your class. You can consult your respective professors on the subject matter. Okay, so this is one of the diagram in the textbook. You can see the curve beam. Okay, I'm going to talk about curve beams in bending. Okay, this is among the depiction of curve beams. You can see the neutral axis. You can see the centroid axis. Okay, the if you remember in the angular in class, the radius, the origin, okay, the theta, and everything. This is the picture of the picture lah. Okay, so what is a curve beam? Okay, curve beam, things that you can see what curve lah, okay, like hooks. Okay, like I'm curving this my finger. I curve like this, making like resemble a hook. Okay, a hook like this. Okay, like a hook ah. Okay, a hook. Okay, hook. A hook is a example of a curve beam. Okay, it is a non-linear stress distribution because compared to the linear, it is a linear. It is a from compared to the straight, but now it is a curve. So a curve, if it is called a non-linear stress distribution, curve beam exhibit a hyperbolic stress distribution, unlike linear distribution in straight beam. This distinction is essential in structural design where curve component endure complex loading condition. Okay. Uh, you can see curve beams everywhere in your life. Okay, the hook. Okay, the hook where you put your clothes, on the hook. It is a curved beam. It's actually a curved beam. Okay, it has a centroid and neutral axis. In curved beam, the neutral axis differs from centroid axis, affecting stress and deformation. Okay, you can see in the picture, in the textbook here, you can see the centroid axis, from this here, centroid axis, and then this will become this also the neutral axis. You can see the position of neutral axis is different from position of central axis. Central axis is the middle one lah. Neutral axis is or slightly upward, depending if you're doing compression or bending lah, kan? Okay. So, uh, okay. Application in engineering, curve beam like crane hooks are designed to handle both bending and axial force, utilizing precise stress calculation for safety and efficiency. Okay. You can see the symmetric cross section, the key assumption and notation. Okay, so uh, this topic and all other topics, we try to simplify things out. So because we simplify things out, we can easily make calculation for it lah. Do mathematical calculation, everything of it. Okay, so there must be key assumption and notation. Okay, we must assume it to become symmetric cross section. The cross section is symmetric in bending plane. Simplified we so that we can simplify stress calculation and ensuring uniform behavior under loading. Okay. Planar cross section force bending. After bending, the cross section of the beam remain planar. This is a critical assumption for accurate stress assessment. And elastic modulus consistency. Okay, elastic modulus is the same as for tension and compression, ensuring balance auxiliary response. Okay, so that why we must assume consistent. Okay. Naturally, when uh, the things become expanded and everything, it will might it might be the modulus changes, okay, because of heating and everything. Okay, so some part of it, originally, they say originally it is strong. Upon heating, that part is not become stronger anymore. Okay, not become stronger anymore. This is things like they call so that the elastic modulus is not the same anymore. Okay, for to simplify calculation, to make it easier for calculate, we assume that it to become consistent stress modulus, elastic modulus lah, kan? Okay, so the stress curve beam stress formula, stress is calculated using this equation, which is you can see it better using the textbook, where m is the bending moment, y is the distance from neutral axis, and a is the cross sectional area, where the e is the distance between neutral and central axis. Hyperbolic distribution. Okay. Curve uh, curve beam exhibit hyperbolic stress distribution with maximum stress on the outer and inner fiber. Distribution is unlike the linear pattern in straight beams. Okay. Hyperbolic meaning that it up and down, up and down, up and down. Okay. Because of the hook, okay, because of the curve beam, like say my finger, this is my finger, in your finger, you can make it as a hook like this. Okay. A hook like this. Okay. So this is the this is what I mean lah. If we calculate the stress, this part will become up, this part will become down, and this is hyperbolic. The graph will become hyperbolic, up and down, up and down, up and down. Okay, so that this thing lah. Okay, the critical application, because some meaning that to say some part is strong, some part is uh weak. Okay, some part is strong, some part is weak, and it is interchangeable. So uh, uh, so the critical calculation, so that we can calculate the exact amount, so that when we choose we can choose it to become safe lah. We can choose the material that is safe for usage. Okay. Okay, bending stress and axial stress. Okay, it is combined axial and bending stress and axial stress. When a hook, let's say my finger lah, and your finger, you can make it a hook like this, okay, and then you put loading like this lah, whatever load, whatever loading lah, kan, you put like this kan, okay, you put the finger, okay, this is the finger, I I make my finger like a hook like this, and then I apply the load, okay, let's say this like this, I force my finger down, okay, it become the bending stress. Okay, this portion become bending stress, and also axial stress going downwards. Okay, this is a combination of axial and bending stress. So that uh, so for example, C clamp under load lah. A C clamp supporting heavy load experience combined axial and bending stress crucial for predicting performance and safety. So naturally, bending, the things that make it at a hook is more stronger lah. Is more stronger. Okay, so it's rarely we can see the hook be broken. But of course, upon usage and usage prolonged usage, it may be broken. Okay, but it is a natural thing lah. When you say you can see with your eye the traces of fatigues, crack and everything, better you change the new thing lah. Okay. So I think that's all for the video right now. Inshallah we meet in the next video. Thank you very much. Okay.